Hello, today we're going to do a little soldering with some flux diluted with 91% isopropyl alcohol, and we'll be soldering some Xilinx XC9536XL surface mount chips. These chips will be soldering them onto a eBay breakout board. It's a double-sided board. We'll be using the 0.8mm side. And top of the screen there, I've got a brass cleaning unit. Helps keep the tip of the soldering iron nice and shiny. We're going to apply flux pretty regularly. That's going to help the solder flow very evenly. Now, these chips are actually pretty small. Those pins are very delicate, and I'm going to be hand placing each of them. Yeah, I'm going to mess up this one a little bit when I use the soldering iron. By the way, the green soldering iron there is just a wood-burning soldering iron you can pick up from Michaels. There's something special about it. It's using the standard tip that came with it. But it works pretty well. Going to clean it a little bit. And then I'm just going to dab this, just a tiny amount of rosin core solder onto the tip. And this is just to load a little solder onto the tip so that it will flow onto the pins. And right here I knock the chip off just a little bit. And I'm going to spend a little bit of time trying to fix it, but ultimately I'm going to pop that chip off and just do it from scratch. I'm actually moving the chip around my fingers, and it's actually not too bad. The soldering iron heat is pretty limited to a small area just at the tip of the soldering iron, so I'm not too worried about burning my fingers. Yeah, there, I'm still trying to move that chip around, and it's just not wanting to line up, so I'm gonna just pop it off and just do it again. Yeah, it doesn't want to split. There we go. Thankfully, none of the pins bent, so I can actually just resolder it on as it was before. I'm going to apply a little bit more flux just because as the flux dries out, it's not as effective. With 0.8mm pitch leads, you could probably just eyeball it without the aid of a magnifying glass. It wasn't too difficult for me, although every now and then I had to just sort of take a closer look at it. So when I solder these leads, I'm actually heating up the traces leading up to the leads, and I'm letting the solder just ride the traces towards the lead itself. And once I see that it's been tagged and tacked down in one corner, I'll basically just apply the tip of the iron that's carrying a little solder onto the top, and I'll sweep it out, and that basically just lets the solder run the course of the lead. You can tell when it's good when the leads go from the sort of dull oxidized gray to a nice shiny silver. Apply a little bit more flux on each side of the leads. Just a tiny dash more rosin core solder. And basically just gently apply a little bit of heat, and the solder will just wick right on. It's actually pretty easy. All of the solder that I use is lead-free, so it does take a little bit more heat. So this wood-burning iron actually does a pretty good job of transferring the heat there. So I'm just using a Q-tip. If some of the thicker paste gets on, it's not that big of a deal. We'll be cleaning it off with a little bit of pure isopropyl in a little bit. So right now I'm taking the metal lid off of a can, pouring a little 91% isopropyl in there, and then I'm just going to scrub the the chip leads and the board down with the alcohol and take as much of that flux residue off as I can. The residue doesn't really hurt the chip much, but if the chip heats up, it could become conductive. It could just, it's kind of sticky. So if you're going to handle the chip a lot, it's just nice to clean it. So I'm scrubbing it back and forth, and I'm also applying a rolling motion, and that helps pick up some of the flux residue. So a couple of passes, and then use the other end to dry it off, and it looks pretty clean. Yeah, it looks really good. Nice and shiny all around. Some of the unevenness, that's just simply the solder surface being blobby. So, alright, one down, 4 more to go, and I'm just going to sort of do a quick flyby here and just go super fast. So unlike reflow soldering where you're using a heated oven or a pan, the chip isn't going to float and sort of self-seed itself. So each time we do a new chip, we need to make sure that we're tagging and tacking down one of the leads so that the chip doesn't move. But once that's done, you can pretty much just sort of run your iron that's loaded with a little bit of solder and just wet all of the leads. And the best way to tell is when the lead goes from sort of that gray to a shinier appearance. And if you get any kind of bridging between the two pins, just apply a little bit of flux and then slide your iron towards it and then away. And what the flux is going to do is it's just when it heats up, it's just going to push the solder apart, and the solder mask on the PCB is going to also aid with that. Yep, there we go, 2 done. Just 3 more. So the first half of the video that was running at normal speed took about 5 minutes, and the remainder of the video is going to take a little bit over 5.5 minutes, but it took about 15.5 minutes in real time. So I basically averaged a little bit better than 2 to 4 minutes per board, soldering these 44 pin quad packs onto these breakout boards. So it wasn't too bad. Later on, what I'll do is I'll take some 0.1 inch headers or the 2.54 millimeter headers, and I'll just add them all around. There's a little bit of a gotcha with the pin numbering, since you'll notice that on the ones that are done, the Xilinx is actually off center, and that's because for chips that have less than the 64 leads, you're basically aligning the chip to the upper left-hand corner. So only the left block with pins 1 through 12 are going to be correctly numbered. The rest of them are just going to be, you need to map them out and keep that in mind with these boards. If you don't want to have to worry about that, I would strongly recommend getting breakout boards that are exactly sized for the type of chip that you're going to be soldering and using on them. For me, these were actually really cheap. I bought like 20 or 30 of them off of eBay, and I definitely see that I'll see myself using more chips later, maybe some with the 64 pin configuration. On the flip side, it'll go up to 100 pins, but that's at the 0.5 millimeter lead pitch. So I haven't tried that yet. I don't have any of those chips, but at some point I'll probably be doing a little bit of that soldering, and so I just kind of figured these boards are the easier way to go. What I ended up doing with the pin numbering and on the board and versus the pin numbering on the chip is I just created a spreadsheet and just mapped out the numbers and applied the labels. So for these chips, I'm going to want to have the JTAG pins pretty clearly marked out. And so what I'm going to do there is in my spreadsheet, I just indicate which pins are it. So later on when I'm ready to program these chips with the JTAG programmer, I'll just plug the wires into the respective pin numbers. And it's pretty straightforward. Yeah. Yeah, it's not hard to line these chips up at all. You just kind of start off on one side and then make sure the opposite corner is more or less lined up. The manufacturing tolerances for these chips, they're a little bit off, so it could look like one corner is going to be misaligned, but once the solder flows, it's actually going to handle any, like, sub-millimeter offsets. So it's not too super critical. Just need to make sure that they're more or less lined up on all four sides, and if one or two pins are a little bit off, it's not going to be the end of the world. You're also noticing I'm not dwelling the soldering iron tip on one spot too much, because that's going to burn the board. And I've had some spots when later on when I'm soldering the headers, that the board actually does cook a little bit with this iron. It's actually not a weak iron. It actually puts out a lot of heat. But yeah, so this is the last one. Gonna clean it up a little bit, and then we'll be done. Thank you so much for watching my video. Please subscribe. I'll be posting more soldering projects, electronic projects. Doing one where I'm basically doing some freehand wiring. So thank you for watching.